Okay. So the first thing we're going to define is actually not polynomial. We're going to define the word monomial. And we're going to switch to the pen first. A monomial is a single mathematical term. It can either be a constant, a variable, or a product of constants and variables. And it can have exponents. It can be raised to positive whole number values. So these are all examples of monomials. So 6 would be a constant because there's no variable. It's a number, so it's called a constant. X, of course, is a variable. X squared is a different variable. It wouldn't be considered a like term with x because it has a different exponent. Here's a product of two variables, x and y, and a product of x and y squared. Those are all monomials. Okay, a polynomial, poly means many. So poly technically means more than one term, but actually a monomial is still considered to be a polynomial. So a polynomial can be just a monomial, or it can be several monomials added together. So this monomial would also be considered to be called a polynomial. It's in that broad description. Here's one with two terms. Here we have a polynomial with 3 terms and another polynomial with 2 terms. They have special names. We already said a monomial is a polynomial with just 1 term. So up here the 6x would be a monomial. A binomial is a polynomial with 2 terms. Brittany, what would be 2 examples of binomials there? Bottom left and right left. Bottom left and bottom right. Good. So these both have 2 terms. This has 3x and positive 1. This has 2x squared, negative 8. So they are both binomials. And the last one is a trinomial. A trinomial is a polynomial with 3 terms. So the last polynomial that we have up there is a trinomial. These are the classifications that we're going to use most often in this class. We'll be talking a lot about binomials and trinomials. So I'll probably do a vocabulary thing on the wall just because there's a lot of vocabulary that you need to know as we talk through this unit. The other kind of quick thing that we need to talk about is degree. The degree of a polynomial is just the highest exponent. So we look at the exponents, the small numbers, and we look at which one is largest, and we name the polynomial's degree based on that exponent. So this polynomial has an exponent of 2. There's no exponent here, but if there was, what would it be? It's kind of there, but it's not there. It would be 1. Good. So it is a second degree polynomial just because the highest exponent is 2. X plus 1 then is a first degree polynomial because the highest exponent is 1. Carson, what degree polynomial would this one be? 4th degree. 4th degree polynomial because the highest exponent is 4. Any questions so far? Does this seem vaguely familiar? Finish talking about this section. Okay, a polynomial is in standard form. When its terms are arranged in order by decreasing degree. So we're going to arrange these polynomials in standard form. I'm going to look for the biggest exponent. My largest exponent is 3, so I'm going to write that term first, 4x to the third. And then I'll get rid of that. My next largest exponent is 2, so I'm going to put this term next, plus 2x squared. Next largest exponent is 1, so plus x. And the next largest exponent is actually 0. We don't have it written here, but when there's no x, we could think of it as x to the 0 power, because anything to the 0 power is what? No, it's not 0. Anything to the 0 power is 1. Anything to the 0 power is 1. Okay, let's try this one. Let's see. Courtney, what would I put first as my first term for this one? Good, x to the 5th. Damien, what would I put next?
Would it be a 4 with negative something?
It would be negative, good.
Or x2?
Negative. No, we do still just look at the exponent. So this would be next, but because it's negative, we write it as a negative. Okay, so we have to keep whatever sign is to the left. So minus x to the 4th. Amy, what would go next? X squared. Paul, what would go next? X. And Adam, what would go last?
Minus 6.
Minus 6, good. Okay, any questions about that? Okay, let's go to the meat of our lesson today, which is adding and subtracting polynomials. When you add polynomials, you can only add like terms. So we've done lots of equations or inequalities where we have to combine like terms. That's what we're going to be doing when we're adding polynomials. The terms must contain the same variables raised to the same power. So they're only like terms if they have all the same variables raised to all the same powers. And I've given you 4 steps to do this. First, distribute if necessary. We're not going to have to really distribute whenever we're doing addition because we don't have to distribute the addition sign, but when we do subtraction, we will need to distribute that. And we're going to circle like terms, and we're going to include that sign to the left so we don't forget what the sign is. Add all the like terms, cross them out when we're done, and then make sure you write your answer in standard form. So the first thing I'm going to do is just get rid of those parentheses. Technically, I'm distributing this plus sign. I'm doing plus 3x and plus 8. That makes it a little easier to work with. Okay, now my like terms, I'm going to look at my first term. It's an x. I have 7x. So I'm going to find all of the terms that have x. I also have plus 3x. Notice I am including the plus sign when I circle it so I don't get mixed up in adding my signs. There are no more x's, so I'm going to add those two together. 7 plus 3x is 10x. Now I'm going to cross them out just so that I know that I used them already. Okay, now I go to my next available term, which is plus 1. The other constant is plus 8. So I add those together, and I get plus 9. Is that in standard form? Yes. Yeah, we have exponent of 1 here and technically an exponent of 0 here, so we're good. Okay, let's take a look at the next one. Austin, what's the first thing I'm going to do? What did I do first? And Good. So I'm just gonna get rid of the parentheses in this case. Adam, looking at my first term, are there any other terms that are like that term?
Yes, 6x squared.
Good. I'm gonna circle the positive sign. When I add those together, what do I get?
9x to the power of 4.
No. When I add like terms, I don't change the exponent.
Oh, just 9x.
It would just be 9x squared. Later on, when we multiply exponents, we will add them. But when we are just adding, we don't do anything with the exponents because these are just like terms. It's like we have 3x squares and we have 6x squared, and we just put them together, so now we have 9 of them. Okay, crossing those out. Let's go to the next term. Courtney, do we have any other that are like 2x? 4x, and when we combine them, what do we get? Good. And is that in standard form? Yes, good. Any questions? Ooh, did I write your name? Okay. Okay, there's a couple for you to try, so I'm going to pause the recording. And I want you to take a second, even if you think you're good at this, I want you to go through the process of circling the terms, crossing them out. Okay, let's take a look at these together. So first, rewriting without parentheses, we have 6x minus 4 plus 5x plus 7. 6x and 5x are like terms, and when I combine them, I end up with 11x. Negative 4 and 7 are like terms. Here we have a negative. We didn't have that in the previous example. 7 minus 4 is 3, so we have 11x minus 3. Okay, in the next example, as I walked around, most of you did a good job with this, just maybe didn't put it in standard form. So we have 2y plus 9y squared. I'm just going to rewrite this without the parentheses. First term is 2y, and it has a like term of 4y. Combining those gives us 6y. 9y squared is all by itself. There are no other y squared, so we just have 9y squared. And we only have one y to the third power. Now we need to put this in standard form. Aiden, what would that look like in standard form? We'll go first. For the biggest exponent. Good. Good. So on a quiz or test, if I say write your answer in standard form and you don't, you won't get full credit. So make sure you do move it to standard form. Okay, let's take a look together at some of these more complicated examples. I'm going to rewrite this first without parentheses. Now, when we do these, there are a lot of products of variables. So we just have to be very careful that we're picking ones that have this exact same exponents. So looking at this first term, Damien, do you see any other terms that are exactly the same as that first term? Let's make sure. Nope, there are none exactly like it, so we're just going to write that one down. Okay, moving to the next term. Brittany, do you see any others that are exactly like that term? Which one? Good. Negative 8y. Thank you for remembering the negative. When I combine the two, what do I get? Good. Negative 13y. Okay, moving on to the next one, we have negative 3xy squared. Adam, do we have any other terms that are exactly like that one?
Yeah, negative 5xy squared.
Good. And when we combine those, what do we get?
Negative 8xy squared.
Okay, and then we just have plus 3x squared, little lone term. These ones are a little trickier to put in standard form because to find the degree of monomials that have more than one variable, we actually have to add all the exponents together. So this one, the x has a degree of 2, the y has a degree of 1. So this would have a total degree of 3, as would the 8xy squared. So we would write probably this one first. Usually we go alphabetically if they're otherwise equal. Which one would I put next? Would I put the 3x squared or the minus 13y? Courtney? The 3x squared, because it has a degree of 2, and the y has a degree of 1. We won't see as many of these polynomials that we actually work with regularly. Most of our polynomials will have all the same variable, but I wanted to show you some examples like this. Okay, let's take a look at the next one. I'm going to rewrite it without the parentheses. This becomes especially important when we are doing subtraction. Rewriting without the parentheses and distributing the negative sign will be really helpful. Okay, first term we have 6x squared. Austin, do you see any other terms up there exactly like that one? Good. Plus 5x squared, and when I combine those, I get good. 11x squared. Okay, next term I have plus 2xy. Paul, do you see any terms exactly like that one? Which one? Good, and when I combine those, what do I get? Okay, and last I have positive 9. Carson, do you see anything on there? Okay, negative 8, and what do I get when I combine them? 1. Good. So just plus 1. Is this in standard form? Yeah, we could consider this to be in standard form. The degree of this is 2. The degree of this x is 1 and this y is 1. Combined, it would be 2. We'll put the x squared first there. Okay, any questions so far? Okay, we're going to look at subtracting polynomials. Subtracting polynomials is basically the same thing, except that you have to distribute the negative sign. So in that step where we rewrite it without parentheses, we just have to distribute the negative sign. So for our first example, we have 9z squared minus 6z. We have to distribute and have minus 7z squared and minus 5z. What am I going to do next? Well, you just kind of joined us. It hasn't sunk in yet. Aiden, what do I do next? Okay, so what can I add here? Anything?
Negative 7z squared.
Good. And what do I get when I combine those?
2z.
Good. Damien, now what?
Negative 16, 5z.
Negative 5z, good. And I get? Good. And is that in standard form? Yes. Good. Okay, let's take a look at the next one. First, I'm going to distribute the negative sign, remove the parentheses. So this becomes minus 5x squared. When I have minus a negative 6x, what does that become? Positive. And then minus 10. So essentially, you're just changing all of the signs of whatever's in the parentheses after the negative sign because you are distributing that negative. Okay, what do I do next? Carson.
Minus 3x squared. Negative 5x squared.
Okay, and get?
2x squared.
Good. Next. Brittany?
Negative 5x and 6x.
Okay, and I get,
1
good,
x.
1x, or just x. You can write a 1 in front of the x if you want to. And last, Paul?
Negative
3
3.
and -10. Good, I like how you guys are all correcting yourselves when you don't say the negative. What do you get? Good. And is that in standard form? Yeah, most of them will be in standard form because most of the polynomials that they give you, they write them in standard form before you add them. So if you add in order like we're doing, most of the time your answers are going to be in standard form. That's just kind of the thing that if I ask you to put it in standard form on the test, you want to go back and double check to make sure they really all are in standard form. Okay, now I'm going to give you a worksheet, and we're going to do just a couple together. Don't panic when you see this worksheet. It has 30 problems. Some of them are really long. I'm not going to assign you all 30. I'm going to give you like 5 to do tonight. Okay? So with only 5, there's no excuse for anybody not to have their homework done. We're going to do some together, and then you'll have 5 to do on your own. But if you have an example already of what some of them look like, and we do some together, you're going to be more successful when you're doing your homework. Okay, so we're going to do number 1 together. So we have an example of addition. Adam, what's my first step? Distribute, and do I really have anything to distribute here? Distribute and good. So I'm just going to rewrite this one without parentheses. 5p squared minus 3 plus 2p squared minus 3p to the third. What do I do next, Paul?
Add 5p squared,
Mhm.
2p squared.
And what do I get? Aiden, what do I do next?
Add 5p squared,
Negative, just write negative 3p cubed? What about this one? We should do this first. Yeah, so we want to go in order. So the next one we have is negative 3. We don't have any other like terms, so we just write down minus 3. And then the last one, we also don't have any like terms, so it's minus 3p cubed. Now this one is not in standard form. We have to put this in standard form. Carson, what would this look like in standard form? Uh-huh. Good. Make sure you keep all of the negative signs with the problems. Okay, let's see. Number 3 is kind of similar to number 1, so we won't do that together. Let's do number 2 together, because that one has some subtraction in it. Well, what's the first thing that I do? What's that? Get rid of the parentheses. And what do I have to do to that negative sign? Distribute. Good. So we have a to the third minus 2a squared. Now what?
Minus 3a.
It's not just 3a. 3a squared. Uh-huh.
Plus 4.
Good. Austin, what do we do next? Well, let's actually start with this first term. Do I have any like terms that are like this one? An a to the third. See any other a to the thirds up there? 4a to the third. Good. Okay, so when I combine those, what do I get? 1a to the third and 4a to the third. Good. 5 a to the third. Courtney, what next? Okay, and I get? Good. And is that in standard form? Yes, good. And let's do number 5. Paul, what's the first thing that I do? Okay, what do I get? 3 squared plus 1.
Minus 4, minus 4.
Minus what?
3
2a squared. Okay, what do I do next, Brittany? Good. 3a squared minus 2a squared is? Good. 1a squared, or just a squared. Damien, what do we do next? Right here, we just.
I was working to the 1
Okay.
plus 1.
Plus 1 minus 4, what's that? Negative 3. Good. Is that in standard form? Yes. Good. Okay, let's see, this gives you, I want you to do a harder one, so let's skip over, let's do number 11, and then I'll have you do 12. Let's see if I have time to do this. Yes. Okay, we'll do number 11. So what's the first thing that I'm gonna do? Aiden. Okay, so I get 12a to the 5th minus 6a minus 10a to the 3rd. Keep going for me. Yeah, I think it's a 5. Okay, what do I do now, Courtney? Okay, and then I get? Good. Adam, next.
The plus 14.
Okay, so you're kind of jumping ahead and you're putting it in standard form. For right now, you can do it that way, but I want to go in order so we don't miss any terms. So I want to go with this one.
Negative 6.
Do we have any other A's?
Negative 10a.
Okay, and then what do we end up with?
We end up with negative 16a.
Good. And what Adam was doing was perfectly fine to do once you get some proficiency with these. He was going for the a to the 4th right away because he was thinking, I'm going to have to put this in standard form, so I might as well just do it as I go, which you can do. But if you're struggling with this, until you get proficient, you should go in order. Okay, what do I do next, Will? Good. Minus 10a to the 3rd, and then we just have plus 14a to the 4th left over. Karsten, put this in standard form for us.
14a to the 5th. 14a to the 4th. And negative 10a to the 3rd. And negative 16a.
Good, you guys are champions with these negative signs. You're doing really well with this today. Okay, what I want you to do for your assignment is 3, 4, 6, 7, and
16.
16.
Yeah.
It's one off.
Morning.
No, I want you to do 12.
Oh.
16
If you want to
doesn't seem that
do
hard
16, you
anyway.
can do 16. But I want you to do another one that has a negative sign.
16 doesn't seem that hard.